Hello and welcome back. We're in the final part of taking some data from a big old jungle of text strings and making it something a machine and us all here can read and not hate looking at it. Hopefully this one won't run as long. The last two ran a bit longer than expected. We don't have much left to do. So we'll jump right back in with where I said we'd start. So obviously we took care of all the shorthand properties, like say the molecular weight, but what about say this stuff? Solid heat capacity or vapor pressure? Oh, those are important numbers, but they're kind of a mess. Well, the professor showed us one way to do it, but I'm a little bit creative and a little bit determined for some heterodoxy at times, perhaps unorthodoxy, or perhaps just different methods, because hey, you know what? See what all we can do. I'm known for trying out different methods, seeing what works. That sounds better. Let's look at that key value pair again, because we'll be starting at the same place. In that C shorthand, dot items, same idea. Items, which I could spell sometimes. And now here's where things are going to get a bit messy, because I need a way of breaking up that singular value in the dictionary of each list of strings. It's a string that's technically a list of numbers, but it's still just a string. Can't read that. So we're going to make a really rudimentary filter, and you're just gonna have to trust this works, because I'm not sure it works 100%, but it works. Coefficient values, please. I see I've actually written this down here. Yes, that one. And that C props again, please. Coefficient values, and what's this equal to? Hold on your hats, it's gonna get a bit fast. That red hat you got from Greg, take good care of it. We'll call it float x, so it's a number. And then we'll do list comprehension for x in. We'll actually need to filter this, and I'm just going to put the filter directly in. This filter takes only one item. In this case, it's saying, hey, wherever this is true, you can go ahead and return that item to me. And our thing we're using to filter it will be this lambda function, meaning, you know, it's kind of like define function, but I don't feel like writing the definition. I don't feel like dedicating an entire chunk of code and memory for this function that gets used like once or like 10 times, depending on how many properties you put through, and that's it. That's too much work. It really shouldn't be, but sometimes lambda functions are fun, and they're a fun way to have a digital flex on your coding friends. People who don't know coding might just look at you weird and say, why have you done that? Or just be in awe at this weird item. So we'll make sure that the length of this item is not 0, so it's not going to return any blank items. And also, how far should we import this here? I'd like not something. I'd like not this one here, that string. That's why we pulled in string. No, actually, I'll put a string for a line down here. Is space. So it can't be a space, so don't give me spaces, and don't give me blank values. The only thing that should be left now is numbers. Cool, so you will have spaces and blank values. We just want the numbers. And then we need our list, which is to bring these out. See props at each key. And then go ahead and use that split functionality. And please split it on each space. So it'll take this list of items, split it each time it finds a space, and if the item is either a space or 0 items long, it'll discard it because it doesn't get through the filter. Otherwise, it'll pass the filter, be allowed through the list comprehension, and be added into coefficient values. Is it the most effective way of doing this? Probably not. Is it a cool way of doing it? Absolutely. So, for a letter, you'll see where this comes in important. Value in, I'm gonna zip two things together to make sure I've got two identically lengthed lists, kind of staggered, so that they are iterating at the same location. String .ASCII underscore uppercase. That's why we actually bought string in, because I'm not making a dictionary of A, B, C, D. That's a waste of my time. That's a waste of everyone's. They already did that for us. That's what strings here. I can ask for the list of every uppercase ASCII character. Or at least all the Latin alphabet ones. I dream of the day I can punch in a capital Sigma and it'll accept it. Until then, it might actually. Until then, I'll use zip, which will iterate through until it exhausts the shortest item, which case is coefficient values. So how long that is, because as you remember, coefficient values will be only so many items long. So we're still in key val, remember. Props at that value, which case is our shorthand notation for a property, and then add in a letter, so that they're actually be uniquely named, like pvap-A, or pvap-B, or pvap-C. That's an ABC in vapor pressure, and I think we all know what to do with that. There's a bit more of it, but if you guessed Antoine, you're on that step. We've already gone over Antoine, so I won't do too much time on that. I'll also struggle to find the right button, and I'll say it equal to value, which will pull out of coefficient values, which will be, there'll be a list of float x. I could probably have drawn this as a numpy array, but, it works. That should do it. I hope that does it. It's in the exact same way as it is in my notes. So let's run that. Let's run test props with both. I'm feeling dangerous. And let's say test dot. Oh, look at that. We've got some extra properties. Promising. Our A. That's right, the Antoine A for vapor pressure. Let's see what that is. I'm going to take its word that it's 72.55 and 74.475. If we look for water, the first item, we will see vapor pressure is 72.55. Yeah, look at that. The filter worked. You could do some things with like separating a bit nicer and discarding each one individually, but the filter is cool. The filter stays unless it's really slow, but we're learning here. We can be slow. That's fine. So, that's cool. But I don't want to do the Antoine every time by hand. We already did it last time, didn't we? Can't we just make it do it for us? I don't have to figure out that method again, so we're just going to shorthand this. I'd like to define one method, please. We'll do that. We'll define pvape. I think some people would yell at me because I just put a cap on a letter, a method. But, it works. Sometimes pressure is capital P, so just, And we're actually using a slightly different version of the Antoine. I don't have a funny picture I can pull up this time, or not so funny, just an actual picture of the image. but it's a bit more slightly extended. I want to say it's like item 106. Actually, let me see what I can't do. I think I have it stashed somewhere in my notes. Somewhere? We'll see. Real quick. I think. Yeah, there. I just might have it. Let's see. No promise. I know where I stuck it. It's in a weird place. What if it changed? This end of the try. It looks so bad now. Why is it red notch? Let's not worry about it. Do we have the picture? I don't think we do. Can equation 106, was it? Let's see. Oh my. Oh? Sorry, it's 105. You'll have to trust what I'm about to do. Nope, sorry, it's 101, actually. We're gonna drag this over here. Hopefully this doesn't break the recording. I think it's still working. I'll check it later. And you'll notice equation 101. Y is equal to exponent A over B over T plus C. That looks like it, but then there's this LNT term and a D times T to the E. That's a bit strange, but it is just a slightly bigger version of our good and classic Antoine. And that's where we have all those letters. You know, we've got an A, a B, a C. Oh, sorry. An A, a B, a C, and then a D, and then an E. We don't need an F and a G, so those just dropped off. So we'll go ahead and we'll go here. I will say I'd like to define that method. Lucky you, I was almost right on what equation it was. So we'll just do a quick return, actually get stuff back out. And we'll do a numpy.exponent. Again, some of the stuff we've done with Jack's numpy, but we're just going to go here. We don't need Jack's yet. We'll do self dot A plus self dot pvap B divided by the temperature you requested plus we'll do a self. I don't think let's even write this. I'm just going to copy the same thing over and there you go. It's the same thing. That's what I would have written. Pvap A, Pvap B over T, Pvap C times NP log times temperature, Pvap D times the power of T, times T raised to the power of E. That should do it. With that, well, I'd like to see what that thinks it is. So let's go and test, and let's try our one method. Let's get that P vape for, what's a good temperature? What's something we know we could verify? 373.15 kelvins, please. What is our vapor pressure, ladies and gentlemen? It's 101.332. That's close enough to 101.325. We can just call it good enough, and we can all stop looking at it so hard. Actually, if we just drop it to 15, will it like it? No, it needs that extra little change. But you get the point. That's about the boiling point of water. It's at 11325 we need. And let's say I want to see, when does ethanol boil? Well, it says it should be around 78 Celsius. That's a lot of work. So I'm just going to put in a 78.37 plus 273.15, please. And what do we get? What do you know? It's approximately 101,325 within acceptable margins of error. There you go. But let's say I'm crazy and I want everything in here. I want water, I want ethanol, I don't know what else is in the list. I didn't take a good look. What else is in here? We got methane, we got methanol, we got nitrogen. It looks fun here. Anything piquing our interests? Toluene. We love toluene here. Toluene. And while we're at it, I'm not done yet. Let's also go look at the wrong thing. Something else is pretty fun. Chloroform. Now we're talking. Ooh, this could be fun. Chloroform. Let's see if I spelled this all correctly. And let's see how everything does at that nice balmy. I don't know what that number would be. That's 78 Celsius. That's quite toasty. It's like, what? 340 Kelvin, 350 Kelvin? Let's see where we're at 350 Kelvin. Well, the water's still a liquid. The ethanol is boiling. The toluene is firmly a liquid. And the chloroform has since left. I don't know chloroform's boiling point. I think actually if I go test dot I don't think we pulled in boiling points of property, did we? Oh, sorry. It's temperature boiling. There we go. That's because it boils at 334. So yes, it would, in fact, have already turned into a gas. So there you go. We had a bit extra. But there's the method. And look at that. We went from this disgusting illegible mess of text with some /n still in there to something a bit nicer. We kind of put all the properties, and then we made a class, and then we made a bit of a nicer class, and then we even got its vapor pressure as just a function. Incredible. I think we've made Greg proud. In fact, how proud is he of us for learning all this information? I'd say he's about that excited, that proud of what has just happened. I think we're all Greg here. As I remember, it is Self, and we are Greg. So let's get a Greg. I don't know the information there. His hat isn't important, so it really matters is I still didn't remember its method. I learned something cool today, but I've still got some learning to do.